And good morning, everyone. I'm Dana Thompson, Assistant Planetarium Director at the Charles W. Brown Planetarium on the campus of Ball State University. This presentation was created with feedback from the 2017 Live Interactive Planetarium Symposium, or LIPS, participants. And I wasn't able to include everything that I wanted to in my presentation today. So make sure to check out the resources online in the proceedings. And if you can't wait for that, I do have copies of my narrative up here. So lately I've been asking school groups when they come through our planetarium what they think a scientist is. What does a scientist do, and how do they go about doing it? And we usually come up with something that resembles the scientific method. So scientists basically observe the world around them, ask questions based on those observations, and try to answer those questions with new observations. And there's, of course, other things in between that. But one of my favorite explanations of what a scientist is came from a LIPS participant. They said that a scientist is someone who knows how to ask a really good question. And that's exactly right? Scientists use their abilities to ask questions. But I would argue that everybody in our society needs to be able to ask questions, not just scientists. Questioning helps people sift through what they're exposed to every day, what they see on social media, what they see in the news, and so on. And questioning helps people become well-informed and maybe even be able to affect global issues on a small scale. So how can we help with this? How can we help create this questioning public? How can we help people better formulate questions? Well, we have a wonderful medium here with our planetariums. We can educate people, and we can really teach the characteristics of a scientist in all of our presentations, because those characteristics really help with formulating questions. So just to back up a little bit and be more specific, not to be confused with a trait, which is a genetically determined quality. A characteristic can be taught and refined over time. So, of course, some things are innate. However, the degree at which they develop depends on how they are cultivated. So characteristics of a scientist that might come to your mind are listed here. So scientists are careful, curious, creative, logical, objective, observant, open-minded, a risk taker, resourceful, and skeptical. And all of these go into forming questions. So how can we teach these in the planetarium? Well, let's start with careful. How can we teach students to be careful? So let's start with this picture here. What do you see in this picture? Different objects? It's a planet. What planet do you think that is? It is Venus, yeah. And below Venus, you see some numbers. What do you think those are? You can barely see it, but yeah, they're dates. So this is Venus over a series of dates in 2004. Now, what do you notice about Venus? What's happening to it? I'm sorry? It's appearing to get bigger, larger. What else? Phases, yeah. So this LIPS participant said that they would show what Venus looks like on the period of about 200 days and ask students to write down any observations on what they see and how can they explain why they see what they do. So some see that it had phases, and some see that it appears to get bigger or smaller in diameter, but not many see both. And they realized that if they were careful, they would have been able to see both and been better able to explain what's going on. So that's just one activity you can do to help people become careful, more careful. What about careful and observant? So we all mostly we sometimes show constellations in our planetariums. But many of us, or some of us, show the lines, show the constellation pictures, and show the name of the constellation. But maybe instead, give your audience some clues on how to find these constellations. Give them a chance to find it on their own first. Tell them what direction to look for it in. Tell them to look for a backwards question mark in the case of Leo here. And this helps them become more engaged in your presentation and hopefully lets them find it in the real sky, which is really the goal of teaching people constellations, right? What about creativity? Creativity is something that can be taught, unlike a lot of people may have that misconception. One example or one activity that you could do to teach creativity is when you're talking about exoplanets, when you're talking about the characteristics that they have, their period, temperature, composition, and other different characteristics. You can ask them what they might name the planet. What's an appropriate name for the planet, given those characteristics? or have them imagine what it would be like to travel to that planet, or what alien life might look like if there is alien life on it. Curious. So, of course, give time to ask questions, and plan time for divergent questions, but also model and promote ambition. Many people think that ambition precedes curiosity. Logical. So this is a great illustration from a book called An Illustrated Book of Bad Arguments. And it says, look, it's a strange beam of light moving through the sky. I don't know what it is, so it must be aliens visiting us from another planet. So this book does a great job of pointing out the fallacies of arguments. And so be upfront with your students, show them what to look for and what to avoid themselves. Objectivity. So Pluto is a big one, and XKCD deemed this crater on Pluto the debate hole. That's where they're putting all the people who are still arguing about Pluto's planet status. So basically, you can't go on believing everything that you're taught because science evolves and changes. But then also, you can't go on believing something just because you have an emotional connection to it. Observant. So we all make observations, but I love this example from a LIPS participant. They just let daily motion run and ask the students what they observe. They are not too talkative at first, but then they see more little things and they realize they just made an observation. So some groups need to be told what an observation is and taught what it is. And then once they understand that they're making observations, really celebrate that. One great activity for to build observational skills is a compare and contrast. So you can compare two planets, like the example in the lower left here, or I like to compare and contrast our Earth and our Moon. That's a really interesting one because we're about the same distance away from our sun. We're both in the habitable zone, and yet we're very different. Open-minded and curious. So give them hands-on activities that they have a chance to do themselves, so giving them that hands-on approach. Now, Sarah Weiss on the right-hand side here is at the conference. She's a student at Ball State, and she'll be presenting on these activities that we have available at her poster session later on this afternoon. Resourceful. So group activities or team collaborations, but then also interdisciplinary activities and discussions as well. Works well for this. So risk-taking and observant. So lately I've been putting an image up on the dome when school groups are coming in, and when the dome lights up, they can barely see it. So without me even asking, they're trying to guess what it is. They're observing what they can see and taking a risk by guessing. So these images are purposefully put up a little bit weird. So I want you to try to guess what the first image on the left is. Yeah, the Great Orion Nebula, and in the middle, dwarf planet Pluto, and on the right, it is dwarf planet Ceres. You can see the two bright spots in the middle there. Skeptical. Don't put this under a rug. Be upfront, show them examples, show them what to look for so that they are better prepared when they see it in Facebook. And then this is my favorite, skeptical, observant, and a risk taker. So one LIPS participant said that they would just put up the stars in the dome and say things like, you can obviously see that every star in the night sky is the same brightness. Or say things like, you can obviously see that all the stars in the same sky are the same temperature or color. And he would wait for someone to prove him wrong. So his point was to get people to point out that he's wrong and to explain why he's wrong. And it would hopefully allow them to look at clickbait articles a little bit different, to question it. So of course, all of these characteristics are built from a good foundation of knowledge. So learn all that you can this conference and take it back to your institutions because knowledge is coming later on. Thank you very much.
Okay, and believe it or not, Dana, you were under 10 minutes, so we now have almost 2 minutes for questions if anyone has a question.
a particular method of breaking the ice to get them to kind of talk a little bit more. So I usually start with asking them what astronomy is and what we look at in space, and almost everyone knows some of those answers. And it also gives me an idea of where to speak to. Like if they only say basic things, then I can know that they probably don't know about black holes yet, and various other things. So it gives me an idea of who I'm talking to. But then also one of the examples that's in the write-up here, they start with saying that there's no such thing as things as stupid questions, only stupid answers. So the audience is not on the hook for it, the presenter is, and that usually opens it up too.
Any other questions?
What is one of the issues that you deal with your audience that you find difficult? That you personally have?
One of the issues that I find difficult is when kids ask me if astronauts will die going into black holes. So I don't know sometimes how to approach death and dying with certain age groups, but usually it's not an issue. They can handle it, and I just say it would be a very bad day.
You still have time for a question.
The frozen for all eternity is a good compromise to dying. Yeah. Long and skinny, yeah. Definitely.
I'm
Some
afraid that
people-
ends our Q&A time. Sorry, Dana.
Yeah, if you want to know. Thank you for that segue. Okay, so if you want to know more, feel free to talk with me, and there is my write-up up front here. Thank you.
Okay, we have just a couple minutes for AV changeover now. And our next talk will be asking the right questions for the right learners. Bring it over. Welcome to paper session 1A. Those of you who are just coming in will be started here in just a minute or so. We had the request, because things are, of course, being recorded and streamed, that Q&A happens into the mic. So if you have a question at the end of the talk, I will run to you with the mic so that you can speak into the mic. Please wait for me to arrive at your location. Yes. Well, you're on the clock. Okay, welcome to paper session 1A. We're just about to start our second paper. Tony Butterfield will be presenting on asking the right questions of the right learners. And if you're ready.
All right. Good morning. Can everybody hear me? All right. Obviously, I am not Carolyn Sumners. So I am Tony Butterfield. I work for Carolyn, and for all the reasons that I am here, that's some of the things that I want to talk about this morning. Her presentation is about assessment in the planetarium, but I wanted to start off mainly because the reason why I'm up here, talking a little bit about what has happened in Houston. As you know, we had a hurricane, and all of our friends and family were impacted by it, including the museum and our offices. Now, a public service announcement is that if it was a fire, if it was a tornado, it would have been a different issue, but from the insurance company's perspective, it was an excessive freshwater event. And because of that, nothing is covered. So there are lots and lots of people who have lost everything. And because of that, our school calendar started a little bit late because schools were closed. Some student populations had to be assigned to different locations. So our school year actually started like last Monday was our first field trip. And because of that and the reassignment of the school calendar, Carolyn, who is a school teacher for the Houston Independent School District, could not leave because they're obviously trying to get caught up on the days lost. So I'm the graphics guy and I help make the shows. But being a part of the department, I can, tell you about what's been going on with the school groups. Now, plus I carpool with one of the other teachers. So there's, to my right, is our newly remodeled planetarium. We remodeled last March 11th and was the highest resolution theater in the world. We use 10 4K projectors, which makes everything stunning and exciting. But as the school teachers are teaching the kids, there's two parts of their field trip. One part of their field trip is in the classroom, where they do a lab based on a unit. And then there's another part where they change out and they go to the planetarium. Now, the school district is real keen on success through testing, and so there's this massive push to do pre-testing and post-testing to get ready for the big test in the spring. And the testing is so important that the school district teachers are under a lot of pressure to show success, and that can only be shown through increasing test scores. So in the classroom, that's easy to do because they have whiteboards and they have handheld voting and whatnot. But in the planetarium, it's dark. And so when you're behind the podium, we all know, giving a show, that the kids are out there and you're presenting your spiel and you're asking questions and you're kind of on autopilot and you don't know if they're getting it. And the school district wants to make sure they're getting it. And so as a result, there is really no way in the dark to test them pre and post. So what Carolyn has done is we have now started testing out some new technology. And if you kind of think about the old days of buttons on the armrest, we're kind of doing a modern version of that. And what that includes is some radio or wireless, I guess that's the technical term, wireless assessment of each student through a way of voting. And so what we have done through the house computer system is we've integrated this voting method. Now, I'm going to run through her PowerPoint real quick. We just started this, and basically the whole point is what I want to get across is a way of assessment of the students in the dark. She did some samples of some students, and as we go into the new school year, we will be able to do more voting and get more data. But in the beginning, we really were just trying to get it to work. So the way it works is that the kids come in, and they're all given what we kind of nickname as these clickers. These clickers are wireless, and they have raised buttons so that in the dark, which is another issue, is trying to figure out which button to click on. So as the kids file in and take their seats, they're given these clickers. And I have another paper for Carolyn that will go into more about the clickers itself. Part of the school district's assessment is to show specific gains on certain topics that they have not scored well in the previous year's state test. And so these are emphasized during the teacher lesson. Now, just a side note, we have our one planetarium, but we use 2 school district teachers for the one show. The other school teacher is James Wooten, and he will give the presentation up to a certain point, and then Carolyn will trade and she'll give the rest of the presentation. And so if the buses arrive on time, they have the full 45, 50 minutes for their classroom, and so that's how we do school groups. And the school show is every morning from about 9:30 to 10:20. They switch out and they do the lab. So that's the operation of how we do our school kids. And both James Wooten and Carolyn Sumners are actually HISD employees, not employees of the school district until after lunchtime. Not employees of the museum until after lunchtime. So these are some samples of the questions that we've started to ask. And as you can see, we have the right answer and we have a distractor. And the school district is real keen on making sure it's a really good distractor. And so what we're trying to promote here is just a new way of testing and assessing the success of the educator. Because part of the challenge from both Carolyn and James Wooten's point of view is all the other school teachers in this school district have statistics on their success. And there are no statistics on how well we are teaching in the planetarium. And so as a result, this is a method to validate the planetarium field trip. Believe me, there's been lots of discussion about canceling that trip to the planetarium and spending more time in the lab or in the classroom. So it's a constant battle to guarantee that the kids are learning in the planetarium, verifying that they're learning the topics that are going to be on the test, and to test those kids and make sure their scores are going up. These are the actual questions that we've recently used, and I'm going to, I want to pause here because this is a beautiful picture of our theater and our true 8K system, which is stunning. Not to brag, but I'm bragging. Basically, we in the Houston area are a large metropolitan area with like any metropolitan area, an inner city of disadvantaged students. And basically, you can generalize and we'll get more and more data that the more economically disadvantaged they are, the less they will score well on a test. So we see what kind of kids are coming from different schools, and then we can anticipate their weakness and their strengths, and then we can verify that through the testing in the dark with the clickers. I don't want to go into her data, but I can give you her email if you want to ask specific questions. But we are seeing gains, and we are connecting with the kids, and we are teaching in the dark, which is what the school district wants. So part of the question is asking the right question. The other challenge is the fact that a large population of our students are non-English speakers. So English language learners, the vocabulary of the question and the way it's presented needs to be more articulated and slower. I hope that summarizes Carolyn's presentation. I'm Tony, the graphics guy from Houston, but I'm in the department, and if you have any questions, I can try to field them.
We have 40 seconds. We can probably take one question.
All right.
I had a question about how you knew which students had which clickers, because you had data from different groups, disadvantaged languages.
Those were different field trips, so all students get all clickers.
Okay.
We have about 200 seats, and we have about 200 clickers.
We have 12 seconds, which is probably not enough time for a real question.
How do you keep him from walking?
Okay, we just stand at the door and we take it from the kids.
And with that, that is time for our paper session. Thank you very much. All right, we'll now be setting up for Mr. Bob Bonadurer. Also, for any other presenters who may be in the room, you might notice there's a speaker right over the right side of the stage. It looks like you get feedback when you walk under it. So as you're sort of meandering around the stage, don't walk under that speaker on the right side of the stage. For those of you just joining us, welcome to paper session 1A. We'll be starting in about 90 seconds with Bob Bonadurer's excellently titled, Respecting the Astrologer. Okay, I'd like to welcome everybody who's joining us here for paper session 1A. we are about to present Bob Bonadur with Respecting the Astrologer. And Bob, whenever you are ready.
Thank you, Dan, and good morning, everyone, and thanks for coming. This show we've all dealt with before, and I want to repeat in my thing, I'm not an astrologer, but your planetarium visitor might be. How do you handle such a visitor? And just historically, I think most of you know Kepler was an astrologer and an astronomer, so he was both. And if he didn't do astrology, one historian said he would never figured out his 3 laws. So you can respect this astrologer right away, right? Different time, of course, 400 years ago. But he fascinates me, Kepler, and the show we saw last night was great. But he also disparaged astrologers. He, like we may have done or do. He wrote, many rules of astrology add up to nothing. So he kind of knew right away. I mean, he's more of a true astronomer, but some say he had to do astrology to support himself. So, birth of astrology, well, whatever, when we first looked up, we did a show called The First Stargazers, and that's our theater assistant, Charlie, in a cave outfit. But some of you know the story. The first, they built a moon calendar out of a bone, just chopping in little notches to make a calendar. And to me, it was quite natural for astrology to develop, right? I mean, the whole Greek cosmos, it's a perfect place, it's very ordered. You look for signs, and the gods live up there. So it just seems very natural. You have to respect that astrology, that how it was formed. I can totally understand that. And then finding the patterns in the sky, the predictive power, led to more of the astronomy, figuring out how the sky works. So, birth of astronomy, I mean, I'm not going to give you an answer to that. You can read all the history books you want. But the Greeks, of course, really started it to me, and they just figured it out just because they wanted to figure it out. That was just their basic reason. And Aristarchus is one of my favorite. He figured out that the sun was at the center. This book, how many have heard of this book? This is a fantastic book. It's not written by a scientist. It's the history of astronomy. It's called The Sleepwalkers. It's a 1957 book. It's an old book, but it's fantastic. If you're into history of astronomy at all, you just love this book. So he kind of asked Arthur Kessler, why do we do science? And, we're not fully sure what steers science research. We're not entirely aware about the impacts of their discoveries, so we're sleepwalking. Okay, there's no end game to it. And Thomas Kuhn, I don't know if you've heard of, how many have heard of Thomas Kuhn? The Structures of Scientific Revolution. Kind of the same idea about why we do science. We can't figure something out, so it opens the door to new ways to figuring things out. And he labeled the whole paradigm shift. And there's no linear progression in science, and he argued that there's no absolute truth. Gets into philosophy. I'm not going to go there, but anyway. So how many have heard this? Okay, we've all heard it. And part of my talk is just when I used to hear this, I would start going like this, and just in my countenance, in my face probably looked really pissed. And remember, 93% of communication is nonverbal. So if you're looking at your audience member like, you're not doing your planetarium a very good service. So anyway, this was said to me many times in 1981, 1982, it just goes on and on. So it happens every year, and when I had to send my paper into Dale Smith, is he in here? On time. Look where Dale works. And he actually had a teaching contract sent to him with this on it. Okay. And he wouldn't sign it, right, Dale? So we all have our stories, and we could tell these in the hospitality suite, and they're fun stories, don't get me wrong. I mean, we've all been called this. And the difference, you got to respect our public. I mean, they sound the same, they're very similar. I wouldn't really expect an average person to know the difference. And sometimes we come across as, they should know. They should know the difference. And anyway, so what do you think? Google. I just Googled these two. Who wins? How many say astronomy will have more results? How many say astrology will have more results? 93 million for astrology. We win! So, and I was with you. I was shocked to find this. So, and we all know about Carl Sagan. Astrology is bunk. It's fraud. Yeah. I mean, he brought it out. I mean, it was good, but I don't think he, converted any astrologers. And this talk is not about converting astrologers. So I had to go do some research. You got to visit their websites, right? So it still kind of boggles my mind sometimes, the whole idea of astrology, but I get it. And I just, try to respect it. What percentage of Americans think astrology is not at all scientific? I think we're running out of time, so I'm gonna, 55%. Okay. So here's the graph. So we're actually going down. We're getting, more. So 1983, I'd love to study this more and find out, what caused these ups and downs, This is 2012 from NSF. I don't have anything. I know that's 5 years ago, but I got to imagine that's dipped even lower, I would guess, sadly. I found this doing the research, the horoscope. Dr. Tyson has got away with words. And I guess he came up with this. That's what I found. But I'll love his quote. The good thing about science is that it's true whether or not you believe in it. And then I love the gravity stuff. We all get the moon questions about, and the doctor had more gravity than you did. So our latest show was about battles in astronomy. And of course, this is one, astronomy versus astrology. So we did a little segment on this. And, I had to write it up, right, in the script. And so anyway, blah, blah, blah. I'll just go on to the next one. It's just your basic history, and they're both curious astronomers, astrologers, and part of what I started the talk out with. Anyway, but the kids in the show, they just say both camps are just different tools to connect to the stars. And that's all they're doing. That's what we're doing. We're just trying to connect to the stars. And we say it, astronomy is a science. We don't really go into what science is exactly, but astrology is a belief. So, how we addressed it. But in our live shows, Wisconsin Stargazing, I like to say that zodiac constellation are timekeepers. How many of them are there? 12. How many months do we have? 12. And so they get right away that these were timekeepers. So I kind of stay away from the whole predictive power type stuff, okay? And people know their signs, so, never look for your sign on your birthday. We show the zodiac almost every show. It's popular. And we try to tie it in and teach things. And if I have older kids in the audience, high school, I say astrology doesn't work very well. And then if I'm really getting snarky, I'll say it doesn't work at all. But, so, my respectfulness can, I love this quote. No pessimist ever discovered the secret of the stars or sailed to an uncharted land or opened a new doorway for the human spirit. Helen Keller. And so I just adapted that. No disrespectful planetarium director ever got one of their astrology-minded readers curious about the wonders of astronomy, or it's supposed to say science, I think or the joys of science. So again, if we're disrespectful, even with our facial expressions, I don't know. I've learned, I don't know if it's just age, I've learned to mellow out. I just don't get pissed off at the astrologers anymore. Or think I'm better, I've gotten away from it. And I'll leave you with this. If you haven't read this book, this is another great book. Feynman's The Pleasure of Finding Things Out. And I love his just first paragraph in the book, The Beauty of a Flower. I have a friend who's an artist, and he's somewhat taken with the view that I don't agree with. He'll look up at a flower and say, look how beautiful it is. And I'll agree, and he says, you see, as an artist, I can appreciate this, or how beautiful it is, but you as a scientist take it all apart, and it becomes a dull thing. And I think he's kind of nutty. I'm not going to get into art and science, but But he just goes on, and you look into a flower, and you see the cells and everything. It's beautiful when we look at it at different levels. And Feynman's just fantastic, and it's just a great book. So, zero, last stop. I think that's it. Okay, timed it well. Dan was giving me great time. Time for questions, or?
Yes, you still have 2 minutes for questions.
Okay. Dina. Oh, you got to run. Sorry, Dan.
So yeah, I had a student apply to the planetarium, and they said that they were really interested in learning about astrology in their application. And I politely informed them about the differences and what we do there. And they had a wonderful response. They said, "Thank you so much for explaining that to me. I obviously have a lot to learn at your institution and would love the job." So like just being respectful and like explaining, like it takes it a long way. So,
Exactly. Yeah. You
Not
just
really a question, just a comment. Thank you.
Okay. By the way, our marketing director at the museum is totally into astrology, and it's just we kid. It's actually really nice. We kid each other. It's great. I mean, she's not going to change, but anyway, Mark.
Yeah, so one other point is that astrology often gets tied in with culture and religion. So I'm half Indian, and to Indians, astrology is very important. None of my cousins got married without consulting an astrologer. So if you become too dismissive, you're dismissing one of the world's major cultures, one of the world's major religions. So
Exactly.
another reason to be careful.
Yeah, I mean, I really understand the whole reason for astrology, and it's very natural and it's very important.
Similarly, we have those people that visit the planetarium that do not think we went to the moon.
That's a different
I
story.
have a hard time keeping my patience with them.
Breathe deep.
I don't know if I can get there in 20 seconds, but I'll try.
But, sorry.
So my favorite astrology encounter, a newspaper reporter being rather frustrated with me, saying that you keep telling me the stars have no influence on the Earth or anybody, and I said, well, that's not completely true, because without the stars I wouldn't have a job.
Exactly. This, it keeps us in business, right? Just explaining the difference.
Okay, so I've got to cut you off, Bob, and we've got to start our next changeover for our next paper. Thank you very much. And our next paper will be Cosmic Conversations. Will audience members talk to each other? Okay, while we have the AV setup going too, I wanted to mention there was a really cool article I saw a few weeks ago that was looking at the increasing popularity of astrology and other beliefs like crystal healing with the youth. That's sort of just like born out of hopelessness with the world. So that's a really good thing to consider too. Welcome to paper session 1A. We'll be getting started with our next paper in about 1 minute. Okay, welcome to paper session 1A. We are about to get started with Morgan Renberg and Cosmic Conversations. Will audience members talk to each other? Whenever you're ready.
All right, well, good morning, and I'd like to talk a little bit today about how we bring some more engagement into our planetaria. And I think this is a topic we've all been thinking about for a long time, but I would wager that there's one part of the planetarium experience we haven't thought that much about. And that's what happens when it's over. Think back to all of the shows that you've seen over the years, and I would bet that most of them have ended in one of two ways. Either the show ends and we all leave, we go off back to our school or our planetarium or our museum or our science center, or you have an opportunity for question and answer. That's how our sessions are ending right now. And here and there, maybe it works a little bit differently, but by and large, either you leave or you get a chance to ask some questions. The problem is that both of these approaches reinforce the idea that our guests are coming into the planetarium simply to get knowledge from us. Whether that's a scientist or a science ambassador, they don't have anything to contribute, and we're not allowing them the opportunity to contribute as well. They can ask a question, we say it's good or bad, but that we don't get the opportunity to sort of learn from them. And we wanted to take the opportunity to think about, could we sort of improve upon this part of the planetarium experience? So that instead of having this sort of unidirectional question and answer, we had a sort of a more wide-ranging conversation where audience members could communicate with one another as well as back and forth with our presenter. And hopefully this would allow our guests to feel part of the scientific enterprise. And then they would feel empowered to go home and reach out to their networks and sort of take on that role of science ambassador and understand a little bit better the process by which science is done. And to do this, we put together a series of planetarium shows at the University of Colorado's Fisk Planetarium entitled Above and Beyond Cosmic Conversations. And the idea of this series was to explore areas where science and society intersect. So this isn't just what's the science of black holes, for example, but instead we might look at something like, isn't it a funny paradox that on a world full of water, in a universe full of water, we have a tremendous problem with water scarcity? Now, that's not a sort of a normal planetarium topic, and we covered biology and chemistry and geology as well as astronomy and physics. And we were training graduate student scientists to give these presentations, these narrative stories, in areas outside of their area of expertise. So we wanted to at first level them with the audience by having to go forth and learn something themselves and not just draw on their wide knowledge. But then after our presentation, we would turn it around and then not ask, do you have any questions, but ask, instead we'll ask you a question and we'd like to hear what you have to tell us about that. And these questions kind of fell into one of a couple of categories. And one category was questions sort of designed to provide information back to the presenter. So for example, when we had a presentation about the health effects of light at night, first we didn't mention a single word about not being able to see the stars, because that's a minor issue relative to all of the other problems that light pollution gives us. But then we asked the question, tell us about ways you've seen your friends, your family, yourself affected by light at night. And then there's, it's kind of a messy boundary between these, but another kind of question is mostly designed to elicit interaction between audience members. And so, for example, after we talked about the sort of opportunities and costs of human spaceflight, we ask the audience to pick. Would you rather have one human mission to Mars, 4 or 5 humans on the surface of Mars, or 20 Curiosity-style rovers scattered all over the planet? And you can easily imagine a couple of defensible positions amongst that. Or after another presentation in which we were exploring how over 10,000 years we've modified the things that we eat and how we've changed our society sort of in reflection of that, we posed the question, well, given what we've talked about with genetically modified food, how do we balance the potential problems that GMOs might cause against the very real threat of 1 billion hungry people on Earth. And that offers a whole spectrum of positions that audience members can pick up and think about. And so we want to enable them without a whole lot of effort to find something that they probably agree with and engage with the rest of the audience, with the presenters on that front. So did it work? Most of the time. We had pretty good success. We did about 24 of these programs spanning somewhere around 2.5 years. And most of the time we had a pretty good engagement with the audience. And I'd say that kind of fell into 4 categories. And the first category is when it didn't work. And if you weren't really careful, you'd fall right back into that Q&A mindset. And maybe you'd ask the audience a question, but they'd ignore you and turn around and ask you a question, and then you're in that familiar rut, and it's really, really hard to get out of that when you're there. And then our second and third groups consisted of having a few people in the audience sort of join in and participate in that conversation, either sort of shallowly and trivially, or in like a deep, meaningful way. There were people who were clearly very knowledgeable and very passionate about the subject matter at hand that could really engage each other and illustrate to the rest of our audience the wide sort of ranging views that one could have on a topic like this. Now, what it meant to be a few sort of depended. An average single show audience could be anywhere from 20 or 40 all the way up to 200. And so that really depended what you call few versus what we were sort of seeing as the holy grail, which was to get the audience broadly involved, the many participants model. But that wouldn't have to be exactly what you considered the best outcome. And unsurprising to all the educators in the room, what we found worked best to get this really broad participation is when we asked questions that allowed people to draw on their own personal lived experiences. Because you don't have to think very hard to come up with something that you've experienced in your life. And I put here the most successful question that we ever had, and it was at the end of a program called Craziest Creatures on Earth that explored the sort of diversity of life on Earth and evolution through the lens of how we would expect to find alien life out there in the universe. It was delivered by a biologist, and he asked the simple question, what's your favorite animal adaptation? And this got responses all the way from early elementary school kids up through senior citizens. And critically, it gave responses that he'd never thought of. Things that he knew about but had never considered an adaptation, or adaptations that he didn't even know about. And that's exactly what we mean by saying that the wider audience, the general public, has something to contribute to the idea of the scientific process. So I'll just finish here with the question, should you try this at home? And the answer is, I don't know. There's a really, I think the ultimate goal of sort of decentering the scientist or the science ambassador in the experience is a really important and really powerful one. And I think that this achieves that pretty well. I also think that it made for a really effective way to evaluate our programs, because just like in a classroom, if you have to then ask somebody to generate original ideas based on the things you were just talking about, you'll find out really quickly whether or not you were clear in explaining or outlining the various ideas. But it's a lot of work. Just sitting down and coming up with that little question could take hours. And you need a presenter who's not only comfortable with talking about the science, but moderating what could be a pretty freewheeling and open discussion, having sort of that extra level of time management on top of that. And sometimes people just got really angry because you were doing something different. They weren't expecting to see, to sort of have to participate, and that left them with a bad taste in their mouth. So I'm really happy with how it turned out. I'm not really eager to go back and try to do it again. So take that as you will, and I think we have some time for questions.
You do. We, in fact, have 2.5 minutes for questions.
Did you find any correlation with age, that younger people were more likely to engage and older people not, or the other way around?
So I'd say it's like a parabola, where young people and relatively old people, very eager to engage, college students there for extra credit, somewhat less likely. We're on a college campus, so that would made up the bulk of our audience often. But I'd say, like, not to be too specific, but people, sort of senior citizen age and elementary school kids, most excited. Not always the most knowledgeable.
So I was wondering, is having a plan from the audience asking a question, is that a good strategy for getting people to be engaged?
Yes. We struggled, we all have this experience in the classroom. You ask a question, nobody answers. And when you're in school, or especially if you're in college and they're paying $50,000 to be there, you can wait them out. But it's harder to get a presenter to want to do that, and that doesn't make such a good experience. And we struggled early on with that. So we found that having the presenter find a friend and tell them a good answer to the question to start things off worked like magic. And say, wait 20 seconds and then answer this, and off to the races you went.
How did you do the transition between the presenter and the participation to get the audience members especially to start talking?
Yeah, that was a challenge to do. We found that sort of introducing at the very beginning of the show, we had a separate host who would sort of introduce the whole concept, and then they appeared again at the end. But we also found with college students, if you allowed any gap at all, they would just bolt for the exits. And so we progressively got quicker and quicker about saying, okay, we didn't say thank you or that's the end of the presentation anymore. We just launched straight into the question. Give no mercy to them to leave because they'll take it.
Did you have any problem with getting really intense and angry discussions?
Not often. I mean, it's usually pretty easy to anticipate when those are going to happen. When we had a conversation about GMOs and we were in Boulder, Colorado, that was going to be a touchy subject.
I'm afraid that's time. Thank you very much. Thank you very much, Morgan. An excellent paper. Really cool. Our next speaker in just a few minutes will be Dave Weinrich. Just give him the facts. For those of you just joining us, welcome to paper session 1A. We'll be getting started here in 1 minute. Okay, everybody, welcome to paper session 1A. We're about to get started now with Dave Weinrich and his paper, Just Give 'em the Facts.
Well, thank you, Dan, and good morning to everyone. Over the past 6 to 8 months, maybe even a little bit longer, I've been noticing more and more that facts don't always convince people. And we've heard quite a bit about it at this conference yesterday about how to address controversy in the planetarium, several references to it today, that facts don't always convince people. I noticed on Facebook and the internet there were increasingly memes that were anti-science, people that don't believe the earth is round, people that don't believe we've been to the moon, or the vaccines are dangerous, or that shouldn't mention evolution, even in terms of talking about astronomy, and that people don't believe society doesn't believe some of the basic things that most of us believe are true. So I got interested and began to, especially on Facebook, some of it was political. I was seeing things that especially some of my relatives were posting that I was interpreting differently than they were. And I started to wonder, how can two people look at the same picture and come to two different conclusions? One of my relatives posted something to this effect: a fence, a wall between Mexico and Guatemala. They interpreted the picture as being true, that this was indeed Mexico on one side and Guatemala on the other. I came to a different conclusion just looking at it. And so I started to do some research. I went online, actually went to, I guess it was Snopes to start with, and found this picture, and there seemed to be indications that this was not Mexico and Guatemala. I mean, I looked at it and said, well, it doesn't look like jungle. I think that southern Mexico is probably jungle. So I found out that it was probably between Israel and Egypt. And so I went online again to Google Maps and went to those locations and found out, indeed, there was a fence there. And to me, that looks a lot more like the Middle East than it does Mexico and Guatemala. But still, people were interpreting it in different ways. And some of it was because of a concept called framing. I don't know if you can read the caption there, but there's a word used there that's you can interpret in different ways. Freeloaders. You know, that's a word that has an image or a frame attached to it. Now, I'm used to, as most of you are, having a scientific mindset. I believe that present the facts, just the facts, everyone is going to come to the same conclusion. And I would try to discuss that with some of my siblings, and it didn't work. It wasn't long before emotions became involved. They became emotional. I became emotional. We're both frustrated. And at the end, we conclude the other person who interpreted the facts differently was, well, fill in the blank. You can see many of these conversations on Facebook, and many of the words that conclusions that people come to, you could not use in a polite conversation. So I also noticed that us planetarians were doing the same thing, discussing these issues and it's saying, well, we just need to nail down the facts more, get people to more facts. It was pointed out yesterday and in some presentations today, there's emotions involved. We're not just rational creatures. We like to think, we go back to the Enlightenment ideas, that we are rational. Two people look at the same thing, they will come to the same conclusions. But that just, I found out, as you probably have as well, that just isn't true. So I began to do some research. And I came across some writings by this man, George Lakoff, that seemed to give me some perspective. And also, just the other day, Richard Thaler won the Nobel Prize in Economics in 2017, and he talked about how our ideas, how our frames influence how we interpret facts. So what is framing? We're not always rational beings. George Lakoff says people think using frames, metaphors, narrative, images, emotions. They're mental structures that are in our brains. We start developing them as soon as we are born. And they may actually depend on whether we come from an authoritative father background or a nurturing parent background. But regardless of where they come from, they are in our minds. Most of the time, we're not even aware of them. Words, most words have a frame behind them. For example, as George Lakoff talks about, if I give you, let's see if the word will float in, there it is. If someone tells you, don't think of an elephant, of course, that's impossible, because as soon as you use the word elephant, something like this comes to your mind. You think of an elephant. And one thing that George talks about is you can't negate a frame by using the word. For example, he gives an example of tax relief. Tax relief is negative just from the word. It's something that's bad, taxes are bad, you need relief from them. Instead of thinking of taxes are a benefit, it's something that I'm part of a society and it's a right. It's a privilege to pay money so that I and other members of society can have the benefits. So framing, we all use them unconsciously. You can't negate a frame by using the word in the frame. The more you activate the frame, the stronger it gets. Here's George Lakoff's most recent book, Don't Think of an Elephant. Another problem is confirmation bias, that we naturally, and again, often at a subconscious level, we're thinking or we're picking our facts to confirm our beliefs and ignore those that do not fit when we're trying to come to a conclusion. In fact, some studies indicate that more intelligent people are better at doing this because they have their greater ability to pick facts that will fit their already what they believe. So, of course, one good thing about science is that science has to be confirmed by many observers, many experiments. So confirmation bias over time will be negated. It's difficult to change minds, even to change our own minds. I notice that myself. Sometimes it's hard for me to talk myself into believing something else. It helps if we can understand where audiences are coming from. As Bob was pointing out, we can't just tell them they're wrong, but we try to understand where they're coming from. We analyze our audience, try to find a common point of interest. One example that someone pointed out, I think it was Neil deGrasse Tyson. If you look at your audience, you recognize that many of them are seniors that were alive during the space race. Perhaps a place where you might begin a planetarium program would be talking about the space race because they're going to be remembering it. I remember teaching in high school, both in the United States and overseas. Sometimes I'd be teaching physics to a group of students who had problems even doing the simplest algebraic formulas. But I would take them from where they were and teach them some algebra and then move them to where I wanted them to be. I had to know where they were coming from. And I like this quote from an article, an interview that was done in Salon magazine with Neil deGrasse Tyson. Key to success is meeting your audience where they are. If you can relate to them in some way and he was talking both about general audiences as well as people who don't believe in what you do. If you can find some commonality and then work from that point, and he was also talking about getting people interested in science that maybe weren't interested in science. And then you can make them excited about anything if you can find some point of commonality.
Okay, with that, we have a couple minutes for questions.
Are the PowerPoints available online for everybody? But there's
Well, the text of all of the papers that are the basis of the PowerPoints will be available on the GLIPA and the Pleiades websites. Any more questions?
Or comments, share examples maybe.
Well, I just want to say this was really, really excellent, Dave. Oh, great.
Well, of course, you never know where people are coming from if you don't ask them what they're thinking about. We were talking about questions are intimidating sometimes, but if instead of asking a question of your audience, you say, I wonder what would happen if, or I wonder how this works, or as soon as you start just saying you're wondering, and then other people start saying, yeah, I was wondering about that too, and they start talking a little bit better, rather than being put on the spot with a question.
I find often it helps audiences if you show genuinely that you care about what they think. This is well, it's a lot easier to do on a one-on-one conversation, but if you start with, what do you think about that? That before you divulge what you think, you might get a more honest, candid response. So I would start with, ask people what they think.
I saw something to the effect that, and I'm paraphrasing, but people don't care about the facts until you show them that you care about them.
And that is the perfect way to call time.